तेजस्विनावधीतमस्तु मा विद्विषावहै। ॐ शान्ति शान्ति शान्तिः।
Okay, let us look at another problem here. Let me just explain the problem first, and then we will first draw the free body and seek to solve the problem, and I will just explain to you how you will go about solving the entire problem. Okay. There is a particular rod here AB. Okay, let me call this as E. So AEB, that is pinned at A to the fixed frame. As you can see here, it is hashed, this is a fixed frame. It is pinned to a body which is L in shape, BCD, okay, pinned to AB at B, and it is pinned to a wheel which is resting on AEB, okay, at E, and this wheel is just it is just standing at E. Okay. Now this BCD is prevented from moving at C, okay, and this is the problem. We wish to find out all the unknowns related to this. Unknowns we will come to. When we say we have to solve the problem, we need to solve for the reactions from the fixed supports and the reactions that appear as an interaction between the rigid bodies. Alright. How do I go about doing this? The first exercise is to understand that there are 3 rigid bodies in this. One rigid body is this AEB, the other rigid body is BCD, and the third rigid body is this particular wheel which is hinged about D. Okay. So there are 3 rigid bodies. This will help me draw the free body diagrams appropriately. One is AB, you can either elect to call it as AEB or AB. The other rigid body is BCD, and the wheel D, okay, with 3 rigid bodies that we have. Okay. What is the first exercise that we need to carry out? We need to remove the restraints that appear due to fixed frame of reference. So let us do that particular exercise to start with. Okay. Now I am going to just shift to simple line diagram. I am just going to draw this AB as a line, BCD as an L, and a circle for a wheel. Okay. So this is a point A, B, we have like this, which is BCD, and you have a wheel. Okay. Now what all have we removed here? We have removed the support that restrains motion in the horizontal direction, which means I should have a reaction from the fixed frame onto this system of planar rigid bodies. So let us call this as C or Cx along the x direction. So we are going to take this as x direction and this is y direction, okay, for our own convenience. At A it is pinned here, which means it does not, the fixed frame of reference does not let it move with respect to the fixed frame of reference at A, both in the vertical and the horizontal direction, which means there will be 2 forces that will be needed by the fixed frame of reference in order to restrain this motion. So let us call this as AY and AX. Okay, so we have 3 unknowns, AX, AY and CX, which have to be found out from equilibrium equations. Okay. Any other In addition, in this particular problem it is given that there is a moment acting here, okay. Think of some motor that is applying a torque, okay, of 120 Newton meter, okay. So I need to transfer that over here. There is a 120 Newton meter that is acting external to this. Assume all the rigid bodies are negligible in mass compared to the 120 Newton meter that is applied, okay. So the first free body concerns this entire system without the fixed frame of reference, okay, and it contains all the three right now, okay. Then we seek to draw the free body of each one of them separately, okay. So let us start with the wheel because that seems to be the simplest one, okay. So this is the wheel D that we seek to draw. What happens here, as we have discussed earlier, in order to draw the free body of this wheel, I need to make sure that I fix AEB and BCD, the two other rigid bodies, fixed to the fixed frame of reference, which means AEB and BCD are not moving at all, okay, in which case this point D of BCD will restrain this wheel from moving in x as well as y direction, which means I will have a reaction that appears on the wheel as dy and dx that is responsible for preventing motion from x and y. Apart from that, you already notice here that it is resting on, the wheel is resting on AEB, which means there is a normal reaction, equal to, let us just call this as NE, or since it is in the y direction we will just call it as EY. We have a question here, will I have a horizontal reaction over here, okay. I do not know, let us say there is, it is not frictionless, it has friction. Let us just introduce Ex for now, okay. So there is a resistance in the x direction, okay. We will come back to simplification as far as this wheel is concerned in a while from now. Have we missed out anything else? The mass of this particular wheel is negligible, which means there are only 2 points that I have to consider, one point of restraint coming from BCD and the other one is due to resting at E, alright. So this is complete as far as wheel D is concerned. Let us seek to draw the other two free bodies. I am going to use line diagrams in order to make it simple. Now let us just look at this particular BCD. If we look at BCD, we have to fix AEB and the wheel to the fixed frame of reference and have a look at what will be the restraints that will be offered. There are 3 points at which restraints will be offered on this BCD. One is at B by AEB, the other is at C due to fixed frame of reference, and the other one is at D due to this wheel remaining unmovable, right, and therefore I will have a reaction, okay. For now, since we already know that we have drawn dx and dy in this direction, we will take equal and opposite directions for this point D. So this is dy dx, alright. So we have finished this. Looking at this, there is a restraint offered here, so we will just stick to that. At B, we will have a restraint in the vertical direction and therefore a force appears. There is a restraint in the horizontal direction, which means there is a force, there is another force Bx that appears. Are we complete? the answer is yes, the mass we have here is negligible, which means we have completed the free body of BCD. Okay, this is x direction, this is y direction. Okay, what remains now is AEB. Okay, again I am going to resort to a line diagram, it makes it simple for drawing. At B, remember I am going to fix BCD as well as the wheel ED, which means at this particular point I will have an equal and opposite reaction, which means I will have By here and Bx like this, simple. At E there is an interaction with the wheel, and therefore I should take the opposite signs of this Ex and Ey and insert those as the forces. So Ex and Ey. Okay. This way we can avoid adding more number of unknowns, we take equal and opposite reactions automatically in this. Okay. At A we have already drawn for the system of rigid body, I will have Ax and Ay appearing. So we have drawn all the free body diagrams here, that of wheel, that of BCD and that of AEB. Okay. The next exercise is to find out what all unknowns do we have to solve. Okay. Let us look at that. The simplest one is this, so I am going to start with this particular wheel. Let me draw that again here. Now we are looking at the unknowns. For the wheel we have dx and dy, Ex and Ey. For this we have already accounted for this, we have Cx that needs to be solved, and we have Bx and By. For this body we have to solve for Ax and Ay, we have already accounted for Ex, Ey, Bx, By, which means Ax and Ay. In all how many? 2 plus 2 4 plus 1 5 plus 4 is 9 unknowns. Can I write down 9 equations? The answer is yes, because I have 1, 2, 3 rigid bodies, each can generate 3 equations, and therefore I can solve for the 9 unknowns. Now if I do it this way it will be a long procedure, so let me look for certain simplifications that I can do. Okay. So simplification 1, if you examine the wheel, let me draw it over here, you have dx, dy, Ex, Ey, these are the only forces that are acting. I am sorry, this is Ex. If I take moment about this particular point, an immediate result is that Ey is along the vertical direction that passes through D, dx and dy do not take part in that moment equilibrium, which means only Ex takes part in the moment equilibrium. So and therefore if I take moment about D, let us say positive, there is only one force that results in that, let us say this radius is r, we already know that this is 0.2 meters, we get it is anti-clockwise in its motion, Ex times 0.2 should be equal to 0, it immediately gives me Ex equals 0. There is no horizontal force that appears on this. Is this clear? Now, if Ex is equal to 0, sigma Fx equals 0 will immediately tell me that dx is equal to 0. Do you get this? I am just going to erase it to make it simple. This is not there, this is not there. Like what we did earlier for a rigid body where there are only two forces, 2 points at which forces are acting, immediate answer that we get here is dy and Ey are opposite to each other. Okay. So, sigma Fy equals 0 gives me Ey equals minus dy. I need not now look at all these 4, I just need one unknown, either Ey or dy, and that will reduce the unknowns in the other free body diagrams. You have dx and dy here, you have Ex and Ey over here, alright. So, let us seek to now remove those so that we simplify. Okay. Please remember, these simplifications will help us solve in a much better way. So, I am going to remove this, I am going to call this as Ey, equal and opposite. Okay. So, I am going to remove this, and shall we just take this instead of Ey, we will just put it as normal reaction. That is the reaction that we see from the ground for a wheel. So, there will be N acting on this. Okay. Here also I do not have this Ex, this is nothing but the N acting from the wheel. Now, we have reduced it, we do not have this anymore, instead it is replaced by a single unknown N. Now, instead of 9 equations we have 1, 2, 3, 4, 5, 6 equations to be solved. Okay. Mind you, in doing that we have already used up all the 3 equations necessary for the wheel. Okay. Going back to this, okay, there are 1, 2, 3, 4 unknowns present in this, 1, 2, 3, 4, 5 unknowns present in this. Okay. In order to solve for this, what would be the points we take in order to find and draw the free body diagram, I am sorry, in order to write down the moment equations. Is there a simplification possible in this? There are simplifications that you can think of, okay, but mind you, I do not have to look at the wheel anymore, that is already taken care of. Correct. Okay, how do we solve for the other unknowns? We already saw 5 here, 5 there. If I take moment about this point, what all unknowns can I avoid? I can avoid Ax, Ay as well as Bx, which means I will have an equation that is in terms of N and By. Is that clear? So, N and By will take part if I have equal 0. This will have N and By taking part. Okay. Go to the other free body. What is the equation that gives me a relationship between N and By only? That is not very difficult. It is the vertical force equilibrium. So, for this I will do this, I will do sigma Fy equals 0, that will involve, it will not involve Bx as well as Cx, it will involve only these two, n and by. This involved n and by, this involved n and by. I can solve using these two equations n and by, alright. Once I have solved for n and by, I am now left with Ax, Ay, Bx, in this case Bx and Cx. If I take the vertical equilibrium here, Ay can be solved for because n and by are already known. So I can solve for that by simply taking sigma Fy equals 0 here. I am now left with the horizontal equilibrium there, that will relate Ax and Bx. If I take the horizontal equilibrium there, it will relate Bx and Cx. Okay. I am sorry, I should have inserted 120 Newton meter here. Okay. So in taking moment about A, I should involve this 120 Newton meter. Okay. So Ax equals Bx, Cx equals Bx are the two equations I get. I need 3 equations because I have Ax, Bx and Cx. How do I get the third one? I will go back to this guy, and if I take moment about this, I avoid Ax and Ay, there is only Cx that needs to be solved here. Remember, this system of planar bodies, free body, will help me solve for Cx directly. This is an important point you have to note. If I do sigma Ma equals 0 here, I will get this directly. Having gotten this directly, I can find out Bx. Having found out Bx, I can find out Ax, which means I have solved for all the unknowns in this particular problem. Okay. And please use this kind of an approach in order to solve the problem, else you will end up with 9 equations with 9 unknowns that needs to be solved, and it will be too cumbersome for you to solve. It is important to look at simplifications that you can do. You will always have to look at, is there a simple way to solve for one unknown or the other. If you do use this approach, it will be possible for you to solve many problems in a very simple way. Okay. You can draw, you can make these strips in order to understand the problem that we discussed. Okay, this is that AB. Let me draw this point of interaction as E. Okay. Now this is a point fixed to the fixed frame, this is a point A fixed to the fixed frame, and remember this is not fixed to the fixed frame, but it fixes BCD and AEB. Okay. Now we will remove each restraint and insert a force. Okay. As before, we will have this as x direction, this as y direction. Okay. This restraint essentially does not allow the point C from moving in this direction. So I am going to remove this and insert a force like this. Okay. Nice to do this kind of an exercise. This gives us understanding. In order to make this body free from the fixed frame, I need to remove A. What does A do? It does not allow the point A to move either in vertical or in horizontal direction. So I am going to insert the two restraints Ax and Ay. Now this is a free body that you have for the entire system. Supposing I have to remove this particular planar body from the system, I need to fix AB and fix BCD. So this point D, pin at point D does not allow it to move. So what I am going to do is I am going to now remove this and insert two forces that prevented movement at D. Okay. In addition, there is at this point E, there is horizontal and vertical restraints. So I can add those two. okay. An equal and opposite reaction has to be inserted over here, okay. I am just going to remove this and insert it over here. There is a restraint this way, equal and opposite restraint has to be inserted over here. Let me just move it over here like this. There is one more like this that I have to insert, okay. An equal and opposite reaction at D. Here we have made a simplification and to find out that these two are 0. So we might as well remove them, which means this is also 0. So you can do this kind of simplification in order to understand how to draw the free body diagram. Now if you look at it, if I have a force over here, let me retain that force, there is another force on this. If I have to remove AEB now, I have to remove the restraint here. When I remove the restraint here, I need to add the two restraints related to that, and this is the free body diagram of BCD. Okay, in a very similar way you can do the same thing. This point is restrained by BCD, and therefore let me just take this out. It will have a reaction like this. A is already restrained, so let me just take those two. These are the two other restraints. At E also I have one restraint that comes from the wheel, okay. I have used something like this, so this is like this is E upward, equal and opposite reaction occurs here, and this is the free body apart from the moment that occurs at A. This should be very clear to you. Try this exercise a few times to get a physical feel of how to draw the free body. Once you become a master at free body diagrams, then a lot of things can be accomplished in a very simple way. Thank you.